Hello, welcome to the course Software Quality Engineering. In last episode, we talked about what is software quality, why software quality is important, and what are the software quality factors. So in this episode, we will cover the topic about software quality assurance. So we will have a brief introduction to what is software quality assurance and what are the components in software quality assurance. First, let's look at the definition of software quality assurance. According to IEEE, software quality assurance is firstly a planned and systematic pattern of all actions necessary to provide adequate confidence that the item or product conforms to established technical requirements. Second, software quality assurance is about a set of activities designed to evaluate the process by which the products are developed or manufactured. So here we see two elements in software quality assurance. The first one is the verification of the product. The second element is the verification of the process. So we should see the difference between software quality assurance and software quality control. So what is quality control? Quality control is a set of activities designed to evaluate the quality of a developed or manufactured product. It's after development, before shipment. The goal is to select the products with high quality and filter out the ones without acceptable quality level. So quality assurance is aiming to minimize the cost of guaranteed quality. It's about the verification of the product and the process. So we can say that software quality assurance is a bigger scope compared to software quality control. According to Daniel Ganning, software quality assurance is a systematic planned set of actions necessary to provide adequate confidence that the software's development process or the maintenance process of a software system product conforms to established functional technical requirements, as well as the managerial requirements of keeping the schedule and operating within the budgetary confines. So here we see, in addition to functional technical requirements, we see software quality assurance is also about the concept of keeping the software development within schedule, under budget. So based on this definition, the objectives of software quality assurance include: first, assuring acceptable level of confidence that the software will conform to functional technical requirements. The second one is that we need to assure an acceptable level of confidence that the software will conform to managerial, scheduling, and budgetary requirements. Third, is also about initiation and management of activities for the improvement and greater efficiency of software development, maintenance, and quality assurance activities, which means we need to continuously evaluate the current activities and improve them. So these are the objectives of software quality assurance. There are three general principles of software quality assurance. The first one is know what are you doing. Know what you are doing. Second one is know what you should be doing. The third one should know how to measure the difference between what you are doing and what you should be doing. Okay. First one, know what you are doing. So we should understand what is being built, how is it being built, and what it currently does. So this means we should have a management structure. We should have a reporting policy. So we should have tracking tools so that we know what is going on in this project. The third general principle is know what you should be doing. So we should have explicit requirements and specifications. How we should follow this requirements and specifications. and we should have a like acceptance test to know that what should be done. And we also should have a frequent user feedback to know what the user actually need. The third general principle is to know the difference, how to measure the difference between what we are doing and what we should be doing. So there are different ways to do the measurement or to do the evaluation. The first one is through formal methods. So in this way, so we use mathematical methods to evaluate what we are doing and compare it to what we should be doing to see whether they agree with each other or whether there's any conflict. The second way is testing. We run the software to know the difference between what we expect and what is actually in the software system. Third way is through inspections. We review the code, we review the document to know whether it meets our expectation. The fourth way is through metrics. We define a set of metrics to measure the software system and compare it with our expectation. So these are three general principles of software quality assurance. So what is included in software quality assurance, or what is the structure of the software quality assurance architecture? So here, this is called the software quality shrine, or you can perceive it as the architecture for the software quality assurance system. So here we can see the whole structure can be divided into 6 parts. The 6 parts marked by different colors. The first part, the roof of the building. So these are pre-project SQA components, which means these components should be conducted before the development of a software project. So this usually includes contract review. Contract review means we need to review our proposal and review the contract to make sure our proposal meets the contract and the contract is valid. Also, at this stage, we should do project development plan and quality plan. So project development plan and quality plan are usually connected. So for example, in our quality plan, we should specify what kind of quality assurance activities should be done at each stage of the software development process. The second part of the architecture is project lifecycle SQA components. So these components are performed at a stage of development lifecycle and operation maintenance. So in this stage, we do several different types of SQA activities, which include software inspections, reviews, audits. So in this way, the experts, the software developers, they would review, they would look at the source code, the document to understand the quality. The second activity is software testing. So run the test cases to see the results. Formal methods is to apply mathematical verification on the software. Also, in this stage, so there are other components, including software maintenance and SQA of external participants. So we should do SQA for external participants because software systems usually include dependency on other external components. For example, we need to use some library from other software systems. So this is the second part of the software quality assurance architecture. The third part is the software is the quality infrastructure components. So in this part, there are different tools, procedures, and the training support for which provide the infrastructure for the prevention and improvement of the software quality issues. For example, so this part provides procedures and working instructions for developers, and also provide supporting tools such as templates and checklists, and also include staff training, instruction, and certification. Also, in this part is deal with configuration management. So configuration management is about how we control the changes in the software system. It is also about document control. So this is quality infrastructure components. The next component is quality management. This component is concerned with how we manage the progress, how we manage the quality and the quality cost of a software project. The next part is software standards, including quality management standards and the project process standards. So quality management standards is what are required for a software organization to get certification. And project process standards is about some guidelines of how a software project should follow to develop high quality software project. Okay, this is about the standards. The base component is the organizational base, is a human components. So this component include specification of the management's role in software quality assurance, such as how the CEO of the company, how the higher management of the company should do their part to ensure the quality of the software. The second element is the SQA unit or the SQA team. Is usually the software quality assurance team, like the QA team. And also, it also includes the SQA trustees, commitment, and forums. So these are the people outside of the SQA team, but they are interested in SQA, or they are very associated with the SQA team. So this is the overall structure of the software quality assurance system. So if there's only one thing you want to remember in this lecture, this is the picture you should remember. So software quality assurance usually includes two parts, or two types of quality assurance. First one is verification. The second type is validation. So what is verification? Verification is about are we building the product right? Are we building the product according to the requirement? Does our product follow the specifications in the requirement? So validation is about are we building the right product? Even though we are following the requirement, does our product meet users' needs, meet users' expectations? That is about the validation. For example, we may build a product that is perfectly following what is specified in requirements, but users don't like it. So we need to do both verification and validation. And we do verification and validation at different stages. So in a software development lifecycle, so there's usually requirement engineering or requirement specification, followed by architecture design, followed by low-level design, and then we have implementation, and then validation or testing. Usually, verification can be done at each stage. At each stage, we can do verification to ensure that the requirements established during the previous phase have been met. That is verification. So validation is usually performed at the end of the development process to ensure its compliance with user expectations. So we can only validate whether the software system meets users' needs after the software system is developed. That's where we do validation, but we can do verification at different stages. So there are usually two types of verification and validation. First step, static. Second is dynamic. So doing static verification and validation means we don't run the software system. So we look at the source code, look at the document, look at the static components. Dynamic verification and validation means we run the software system. So we run the system dynamically, so it produces dynamic outputs. So we can do static verification and validation at different stages, from requirements to architecture, from low-level design to implementation. However, usually we can only do dynamic verification after implementation, because only after implementation we can run the system, we can see the dynamic outputs. But sometimes there's a prototype after requirement specification is finished. A prototype is a simplified version of the software implemented. So we can run this simplified version to do the dynamic verification and the validation. So SQL usually includes 3 goals. The first one is defect prevention. So we want to prevent defects from occurring in the first place. So to do this, we need to do proper training of our people. And we also need to do proper planning and do proper simulation to ensure that defect can be prevented. The second goal is to do defect detection. So if we cannot prevent other defects, so we need to be able to detect those defects in the software artifact. So this includes testing, inspection, and measuring. A third goal is to do defect removal. So after we detect those defects, we should be able to remove them. For example, we can isolate them, correct them, and also we need to verify whether our fixes are valid. So that is for this today's course. So after today's course, there are some action items. The first one is please find your teammates. So ideally, you would have a group of 3, and maximum you can have a group of 4. And please send me the name of your team and the list of your team members, including the names of the students and the student numbers. Please send me by September 16th, because we will have our first lab on September 17th. Also, please sign up on our Slack workspace so you may post your questions on Slack. And also, during the lectures, we will use Slack for QA. And also, please check the assignment TP0, which is due on November 30th. So there may be some specifications in this assignment that will be covered in the next few lectures. But the goal of this assignment is to let you have in mind some questions or some research questions that you want to answer at the end of this term. Okay, Thank you very much.